Hi, welcome everybody. My name is Frank McKenna. I'm here at UC Berkeley. I'm part of the SimCenter team. And as Matt told you, I'm going to talk about the EEUQ, or Earthquake Engineering with Uncertainty Quantification tool. Before I do, let me go through a little disclaimer we have to give for all our talks. Today's webinar is coordinated by the Natural Hazards Engineering Research Infrastructure's Computational Modeling and Simulation Center. This webinar is supported by the National Science Foundation under awards 1612843 and 1520817. Any statements in this webinar are those of the presenter and do not necessarily represent the views of the National Science Foundation. Okay, so let's talk about a quick overview of the outline of what I'm going to do. I'm going to give you a real quick introduction in slides to the SimCenter and to EEUQ. Then we're going to have a hands-on demo that's going to take most of the time. And then finally, if time permitting, we'll have some questions. So let's start with an introduction to SimCenter. So NHERI, or the Natural Hazards Engineering Research Infrastructure, is a large facility in NSF size. That facility is broken down into a number of facilities. NCO is the Network Coordination Office that leads coordination between all the facilities. We have experimental facilities situated around the country. We have a rapid facility, which provides equipment for people going out to study natural disasters. All the data collected by the experimental facilities and the rapid facilities goes to the cyber infrastructure component of NHERI, which is Design Safe, which you pretty much all see through the browser. Design Safe is actually behind the scenes. We've got a lot of data storage and some high performance computers that Design Safe make available to the NHERI researchers. These are all made available through the Agave interface. And then finally, the last and most important, of course, facility is SimCenter, who's responsible for developing tools to aid researchers in natural hazards engineering do their research. And all our tools basically interact with the high performance computers and the data storage that Design Safe provides through Agave. So the SimCenter goals is basically to produce extensible software researchers in natural hazard engineering can use in their research. To do this, basically we are developing an open source computational framework. We're designing that framework to be flexible, extensible, and scalable. We're seeding that framework with data and interfaces to existing simulation tools so that it can be employed in the near term. And finally, we're releasing applications built using this framework that meets the computational needs of researchers in natural hazards engineering. And finally, through the tools, we hope to provide an ecosystem that fosters collaboration between scientists, engineers, public planners, officials, and others trying to improve the resilience of the communities to natural hazards. So the SimCenter itself, to get our tools, basically you go to the website shown here. At the website under Research Tools, you can see the research tools that we are providing. There are a number of them that we have released. All the software for the tools we have released is available on GitHub with the reference shown there on the bottom right of the screen. 3 of these tools are usable now for researchers looking into doing earthquake engineering. Those tools are UQFEM, EEUQ, and PVE. PVE will be there will be a webinar presented on PVE in about 2 weeks, and then we'll have one in UQFEM sometime in June. But today's talk is basically about EEUQ. So the purpose of EEUQ is basically to determine the response of a building subjected to an earthquake event. So this is one building subjected to an earthquake event. The unique features that EEUQ brings that other applications do not provide is uncertainty quantification. That's the biggie. Other things we do is local or remote execution, and also we provide different options for the ground motion selection. So EEUQ, it's basically the important thing to remember, it's not a deterministic application. That is, it doesn't produce a single output result for every response parameter that you're interested in. For example, if you run the application for the response of a building, you do not get one number for the maximum floor acceleration. Instead, EEQ is a UQ application. For each output response, it produces information on the response and some measure of the uncertainty in the computed response. For example, the mean and the standard deviation of that floor acceleration. Now, because EEQ is a UQ application, it requires the users to do additional things that they don't have to do in a traditional earthquake engineering application. Basically, the user has to identify which parameters in their input should be treated as random variables. And then once they identify those parameters, then they have to define some distribution associated with that random parameters. Now, to generate uncertainty quantification requires a lot more computation. Now, EEQ can run these computations in parallel using the cores of your local computer. It can also run these simulations through the cloud using the HPC resources that DesignSafe provides. And in the demo, we'll give you a demonstration of this. So how I'm able to run it either locally or actually run the computations in the cloud is basically, I've done this by splitting EEQ into it's two applications. It's got a front-end user interface that the user interacts with, where they define all the parameters. And then once they select run with this application starts another application in the back end that the user doesn't see. And it's there that all the computations are being done. So basically, the front end creates an input file for the back end. If it's running locally, that will run on the local machine. But if it's running remotely, that input file basically gets sent off to DesignSafe, and then I run an application at DesignSafe to run that input file. So what EEQ actually is, it's a scientific workflow system. That is, it provides the user an interface to allow the user to select from different applications to run in this back-end workflow. And the interface allows the user to specify the inputs for the applications, to schedule the workflow, and also to monitor the progress of the workflow as it's running. Now, we provide a number of applications that run in the back end that are selected in the user input. We have stuff for the structural model. There's applications to provide the different events to the simulation. We don't have options for the analysis or the UQ engine at the moment. Options will come later. And then for the engineering demand parameters results, we have two applications the user gets to choose from. EEQ basically allows the users to play with the different applications to see what the different results are. For example, in this case, we're using the MDOF structural analysis model, the seismic hazard analysis, OpenSeas, Dakota as our UQ engine, and some standard earthquake response. In run 2, basically, I'm switching from the seismic hazard analysis, I'm going to just try stochastic analysis or just use synthetic ground motions. And then finally, in my last run, say I want to use OpenSeas with the stochastic. I'm going to use OpenSeas for the analysis, Dakota for my uncertainty engine. And then I'm going to want some user-defined output. And now, before I demonstrate, let me quickly talk about the manual. The manual has basic installation instructions. To run EEQ, it's not as simply as just downloading EEQ and running. You have to install certain applications on your machine to get it to work. If you just want to run it locally, you have to install Python. If you want to run it remotely, or to run it locally, you also have to install OpenSeas and Dakota. To run it remotely, you just need to install Python. There's instructions on the usage. Troubleshooting. If things go wrong, before you send me an email, if you could look up the troubleshooting section to see, maybe your problem is covered in the troubleshooting section. Finally, there's instruction on where to go for help. Basically, it's either you submit a ticket on DesignSafe or you go to the Slack channel for this tool. And finally, the requirements. The requirements are the important one for researchers. Basically, it's in this section we define what plans we have for the tool. But it's also this section that the users get to influence. If you see any feature you would like added to EEQ, send us an email, and we can see if we can add that to the requirements and then see if we have time with our developer pool to actually put that requirement into the tool itself. So finally, let me do a hands-on demo of the tool. So I'm running a Macintosh here. So the instructions for the Macintosh suggest that you install it on the desktop. So I'm going to run it like it was installed on the desktop. So to run it, basically I just click on the application EEQ. And this brings up the following interface. Resize it a bit here. So let me talk about the interface. Basically, I said we can run it locally or we can run it remotely. So that's what these two buttons are down here for. Run just runs it on your desktop. Run at Design Safe would run the backend application at Design Safe. Get from Design Safe, that's when you actually want to get the results back, bring them back to your computer. When you actually run at Design Safe, it just launches the job and you can go away, go off and do things, or launch multiple jobs and then come back later and get a specific job. We can also exit the application from this bottom right button. To do anything at Design Safe requires that we first log into Design Safe. So that's what this button is here. So let me log in now. Let me just log in to get this going. So there's little messages going up here. As that's where the messages are sent when you do things. If there's a problem, you'll see it up here. So let me talk about this left-hand panel over here. The sim through the EDP, these are where we actually change which application we're actually working on. So as I change any of these, we bring up different things. These are the different applications I showed. And then if I want to switch from one application to another within a particular selection, it's basically going to be switching on these boxes here. So we have the structural analysis model, we have the event, the finite element method, the uncertainty quantification, and our EDPs. So let me quickly launch a job. So the quickest way to launch a job is to use this stochastic ground motion or synthetic ground motions. I'm going to say a magnitude 7, pitch into rupture about 30 kilometers, and let's have a VS30. We're going to make this VS30, say, a random variable. Let's just stick with the default finite element selections for now. So for VS30, let me just enter, say, 350. I'm using a normal distribution, 350. You know, I do have other options, which I pick in the selection. I'm also just running sort of Latin hypercube with 10 samples, so it runs pretty quick. This is a full UQ analysis that I'll obviously do a lot more. So when I click the run button, it brings up this. Typically, all you do now is hit submit. This additional information is when you start getting a little bit more advanced with the tool, basically where it stores the temporary data for the backend to run, and where the applications are, these backend applications are. So let me submit that job now. So this is now running on my desktop, and there's, you know, it's finished. So this automatically takes me to the results panel. In the results panel, I see the peak floor acceleration for floor 1, direction 1. That's the ground level. Peak floor displacement, peak floor acceleration at floor 2 in the 1 degree of freedom direction, displacement that same direction, and then the peak into story drift. So I get this display of the results. I can also look at a more detailed display. And then finally, I can graphically look at the results. And here, when you're graphically, you know, using the left mouse and your right mouse button, you can actually change what's actually being displayed. So left button does what's on the y-axis here, and the right button does what's on the x-axis. And if you have both the left and the right button, you can see the PDF or the CDF of the term just by clicking left or right. Left does the probability density function, and right does the CDF. So that was a quick run. As I said, I'm using this event, stochastic ground motion, and I'm using this MDOF. So let me now go through the different event options that we have. Let me do the peer. So the peer, we can add multiple peer events. For each peer event, we have to go off and choose a file. So we can select the file. I have to give this some sort of name so I can see it in the results. Now, if I run this now, it won't actually run because I have no random variables. So let me put a random variable on the factor. Let me also delete these two here. So let me set a 1 for the mean and a 0.1 on the standard deviation. So this will run the results. Again, you see the output. There's this other option to load a whole directory of files. So if I go to that same directory, it'll actually load all the records in that directory and give them all a factor of 1. So let me do something different. Let me show you now. In my terminal, I'm going to cd to that directory. And I have a file here that I'm going to rename to be records.txt. If I look at records.txt, basically it's a file with the actual which contains the name of the peer record and some factor. So if I now load this directory with that file in there, so you'll see now it's actually loaded, and you set the factors that you automatically want loaded. That's the multiple peer. Hazard-based event. Here we're using OpenSHA to actually go get a record. So before I can use this, I actually have to, in the general information panel where we set the units, I actually have to set a latitude and longitude. So let me set the latitude and longitude for, say, the Campanile. Now this current ground motion selection, this is only going to take one record out of the peer database. So I need to add some random variable, otherwise this is not going to work. So let's change this. Let's add 4 floors. Now let's make the story stiffness in the x direction some random variable. So what this is now doing, like, it's going to OpenSHA, and for the site and the inputs, it's getting back a peak ground acceleration and a response spectrum. And then we're then searching the peer NGA database for the record that best matches the criterion that comes back from OpenSHA. And that's the record that's then used to perform the analysis. Other things we have are the site response. So here the user basically specifies a ground motion at the rock level, and that ground motion is brought up to the surface, and it's that ground motion at the surface that is then provided as input to the building. So let me add a soil. So this is, right now I've just got one soil. Let me add another soil layer. Currently, that's the soil. All the soils are elastic. So I'm going to do two things. I'm going to change the, in the mesh size, I'm going to change that to a larger mesh for these bottom elements. And I'm also going to switch the material from elastic to say the PM4 sand. Let me check the configuration here. So basically you have to specify where OpenSeas is, and I'm basically using this El Centro motion. Now when I'm using the site response tool, right now you do not hit run because right now I've no record. This site response tool, when you use it, basically you have to click on this analyze button. So it's actually going off and doing a site response. So this takes a little while. But if you're bored, the developer threw in a little game you can play. Yeah, I'm not a game expert, as we see. So we'll just wait while this runs a little bit here. What's slowing this down is PM4 sand. While this is waiting, let me, the GWT is the ground water level table. So you can change the water level. We're almost done. Okay, so we're done. So once we're done, we still can look at the mesh. If we want to look at the response in any of the elements, we could go to the element, click on the elements, and then we could look at the different stress strain or the stress versus strain. We can go back to the nodes and look at acceleration. So it's looking at this node here, velocity, displacement. We can look at pretty much any of these quantities. And then now once we have that simulation run, we can then run our tool again. So it has the event and it's now running that event. And there we have our results again. So what else? So there basically, I've pretty much gone through all the different events we can have. The multiple existing, I'm going to save that for next time we have our new tool. That's the purpose of that. And there's also the user application. So if the user has an application, they can specify the application in the arguments file, and then we'll run that application in the background. So let me stick with the stochastic ground motion for my input. Let me go back now to the simulation. So this is a simple stick model. Instead of the stick model, let me use OpenSeas. So this is the input. So if you have an OpenSeas model, which does basically a gravity analysis of the building, you can input that model. I'm now going to input that model. What I need to know from this model is, when I'm using that standard earthquake EDPs, is I need to know where the nodes are on a column line. So that's this 1 and 3. What's getting input there. Let me now jump to the EDPs. So now I have FC, FY, and E. These are new random variables that have come from that OpenSeas script. Let me show you that script to see where these variables are coming from. For those of you who know OpenSeas, it's a string-based interpreted language, and you can set variables in that language. A long time ago in OpenSeas, we added a variable to just like, instead of the set command, there's a pset command. So any variable that the program finds that has a pset instead of a set, it will automatically know that they're to be treated as random variables when it's loaded into this application. And now when I see them as random variables, I have to come in and set some, I have to set some distribution associated with them. So everything, as you see, I like normal. Okay, so we can go off and run this, and now it's going to run these OpenSea simulations. Again, we can have a look at the results if we want. The output, I would say, if you don't like the floor displacements into story drift and you want other stuff, the standard earthquake is pretty much all you need if you're performing a performance-based engineering calculation. But if you want other stuff, you have to use what's called the user-defined option. So the user-defined one, you basically specify what the additional file is. In OpenSea's case, it's the recorder file. With other programs, it'll be something else. But basically, what defines what additional steps is needed to be added to the program for output. And then you need to specify what do you do to that output to actually process it and get it ready for the workflow. So the processing of the output is done by this post-process script. And this run right now is just looking at nodal displacements at node 4 and node 3. So if I run this now, I will see the results hopefully for only node 3. And so there we are, node 3 and node 4 displacement. There's the mean and standard deviation. And there's the results. So now I've pretty much gone through all the options, and I've done 10 simulations of very simple models. When you have larger models, you're going to want to run these at design safe. So let me demonstrate running these at design safe. So I've already logged in. I know I've logged in because if I look at the top button here at the top right, it says log out. So I'm logged in. I can check I'm logged in by having a look at all the jobs I've already run at design safe. So when I click on the get from design safe, it's going to bring up a list of all the jobs I've run. So here's all the jobs I've run. They've all finished. There's a couple in there that have failed. So I'm logged in and design safe is ready for me. So let me run this job now at design safe. So I'm going to go, instead of a run, I'm going to go run at design safe. So when I click run at design safe, I can give it a name, so I can recognize it better in my thing. And then you basically specify the number of nodes you would like and the number of processes you want. So when you're running in parallel, you have to specify this information. Right now, the max number it's set here is 10. That's because I'm only asking for 10 simulations. If I wanted more, this would automatically come back with a higher number if I'd specified more in the EDPs. And then you need to specify the wall time. This thing, as you know, is pretty quick. So I could probably let me just specify a minute here to run it in. And then these other options, again, these are for advanced users, so don't touch anything here. So now I'm going to submit this job. Now what this is doing is getting all the files ready on my local machine. It's then going to transfer all the files from my local machine over to design safe, and then it's going to run this job at design safe. So let me run into design safe here. On the work. Actually, I'm not logged in as the right person. So that job is successfully started now at design safe. It's 629019, blah, blah, blah. I can go get it from design safe. So this is going to now update this tool. So you see that job, it's actually not running yet. It's just pending, and so it's waiting to run at design safe. I can also see that if I just go to design safe. Go to the workspace here. And then if you click on the job status here on the right-hand side of this in the workspace, you'll see, there's EQ webinar. It's now staged. So it goes through a couple of steps. So there, it's updating the thing. So I'm going to go, download a job that I've already run. So that's the retrieve data. So this clicks, left click or right click in any of these jobs brings up this menu. You can refresh the job. That'll show you what the job status is. Retrieve the data, go gets the results. I can also delete the job. That'll just make it so that it wouldn't appear on this screen, but the actual data for the job would actually still exist. So if I want to delete the job and the data, that's what that delete job and data thing was done. Let's actually see if this guy's finished yet. No, it's only in the queue. So here I am now. I'm just going to retrieve that job. I'm not sure what I actually ran previously, but there's the results coming back now from DesignSafe. So that's pretty much the tool. As I say, there's a number of options where the user gets to specify just exactly which application they want to run in this back-end workflow. For each of these panels, you basically specify which application you're going to run. When you've set up the workflow, you run the workflow either locally or at DesignSafe. At any time you want, you can go get results from DesignSafe. And then when you're done, you can exit the tool. Let's see if this guy's finished. Yeah. No, he's still in the queue. Okay. So that is EEUQ. As I say, you can look at DesignSafe to see the status. If you want to go into you actually go in Data Depot and you'll actually see the actual data that's sitting there that I've sent across from my local machine. So under Archive Jobs, we'll see all those jobs. And one of those jobs is the job I've just submitted. So all the input files are here. And when the job is finished, all the output files will be there as well. All right. So back to the web presentation. Questions? Does anybody have any questions? As Matt said at the beginning, if you want to submit a question, you have to send Matt, who is the moderator, something in the chat window. And Matt will send it on to me. I'm not sure how he's going to do that.
Well, I think I'll do it verbally, Frank. Can you hear me okay?
I hear you fine.
Okay, great. Thank you for that introduction. I think it was very helpful. Would you maybe also show people where they access EEUQ, where they download it from?
Sure, sure. Actually, let me show two things while I'm here. Oops. Everybody knows the quickest way to find anything is Google. So EEUQ is available here on the SimCenter's website, which is part of DesignSafe. Under Research Tools, here's where you get all the different tools we've released. And this is the EEUQ. And then to download it, click on that link. That brings you to this page here. The examples I was running is available there. It's an example1.tar. And then depending on whether you're a Mac or a Windows user, you download one of these two applications. And if I may, let me just start this tool one more time. I want to show you one last thing. So let me run the tool again quickly. As I say, this is the quickest way to run it. So here, this applications directory, this is where it's going to store those temporary files. And those files don't go away. They get overwritten every time you run it again. But in this directory, you will find the files. So I'm just going to show you that directory. So that was from the Mac, it's in the documents folder. The document folders contains two directories. When you run it locally, there's a local workdir. And it creates a directory temp.simcenter. And here there's a lot of stuff. If it doesn't work, there's going to be something in this dakota.error file that might explain why it didn't work. This simulation ran, so there's nothing in that error file. This template dir is where everything is staged. So if you don't see any of the workdir.1, 2, 3, 4, 5, that means there's been a problem here. And the thing to look at here is this workflow log. So this is basically where we're running all these back-end applications. And if there's a problem with any of these applications, you're going to see an error message. That error message is currently not brought back to the tool, but it will be in the next release of the tool. Okay, Matt, any questions?
Yes. I guess maybe one other point would be our Slack channel for the tool. You can mention where that might be.
So at DesignSafe, on their Slack channel, we have created a channel specifically for this tool. So let me just bring it up. For some reason I deleted Slack. So there's a channel specifically for this tool. So if you have any questions, so again, I'm in DesignSafe, SimCenter EEQ, there's a channel. So if you have any questions, just throw something in there. So as you all can see, there's no questions on EEQ or nobody's found any bugs. So everything works. All right, anything else, Matt?
Good, yes. So if we talk about importing a model, importing an OpenSeas model.
Sure.
The question is what should be the input for the C line parameter?
Okay, the C line specifies the column. You know, in the EDPs, when I'm doing the standard earthquake, so let me pull one in here again. So this is a little port of flame with 4 nodes. Nodes 1 and 2 are at the bottom, nodes 3 and 4 up above. So I have to specify one column line. So these are the nodes basically at one column line that goes up the building. Because when I now run this with the standard EDP, I see it's getting the floor accelerations at floor 1 and at floor 2. And the interstory drift. So it has to know, I have to know what those nodes are to actually get the displacement at particular floor levels. So those column line, there's basically, you're specifying the nodes at a column line for which these response quantities, the floor accelerations and the interstory drifts are actually calculated from, if that makes sense.
I think it makes sense.
Okay.
Still on inputting structural models, can the OpenSeas model be a Python script, or does it have to be an OpenSeas Tickle script?
Right now it has to be OpenSeas Tickle because I'm running the OpenSeas Tickle interpreter. The next version of the tool, they will have OpenSeas PY being an option. So then it could be instead of specifying OpenSeas, you're going to specify as OpenSeas PY here, and then you can specify your Python script. That's the intent. Great.
And then a follow-up question is, are only line element models allowed, or does it allow
it can be any type of element you want. It can be any model you want, and you just have to give me the nodes at the column lines. I don't care what your model is. If that makes sense.
It does. And another question is, The question is the EEUQ might give a more detailed analysis. I don't know that detailed analysis is the correct term. It might be that accounts for your random
Well, it
variables.
says it produces uncertainty quantification, so it's dealing with the random variables. So that's really what it's doing. So it does a lot more analysis. Let me just say that, I developed OpenSees, which is deterministic application, and for years I thought that's all that was needed. It's only when I started seeing the results from these blind predictions and how dispersed the results were, that I started thinking, we gotta do something different. We gotta start producing the information about how certain we are about our output. Just getting single numbers is really it's not the way to go. There's a famous quote from Jeffers, I think it was 1967. A response quantity without a measure of the uncertainty is practically useless. So, what he's saying is deterministic simulations are practically useless, is what he's saying.
Right. So a follow-up question to that about the detailed analysis is the back end of this tool and how it relates to the back ends of our other tools.
The back end of this tool, basically all the applications at the back end of this tool will exist in all the other tools. For example, they're the same applications in PBE. Many of them are similar to what it can be found in our regional earthquake simulations, those workflows. So, all these applications meet some interface. That interface is what's common across all the tools. So if I can develop an interface for a specific application that exists in the workflow that exists in the regional workflow that doesn't exist in this tool, it can be brought in quite easily.
Okay. The next question: what is the best way to export or access the raw output data?
Well, let me go back to the output there. Right now, when I'm running Dakota, I get this file dakota.tab.out. And this basically, I remember I'm doing 10 simulations. This is my random variable, the VS30. And then these are the results. So you could open this file if you wanted and process it differently, process the results differently. If you want to see the intermediate results, I get 10 work-durs because I'm, again, doing 10 simulations, so I have 10 work-durs. And in each work-dir, I'll see the results.out file for that specific thing. And I'll also see, if I want to capture all the different events that the stochastic model generated, I can have a look at the event file. So they're all, they're all in these. They're all saved for people to look at, and they're saved just because I know you're all researchers and you kind of want to look at that stuff. So that's why I'm saving it. So does that answer that one?
Yes.
Alrighty.
This one kind of goes back to line models versus continuum models. And is this EEUQ building specific? Are we only looking at reinforced concrete or steel structures? There's a follow-up question to this. So why don't you answer that one first?
Well, the first one is no, it's not building specific. The only thing building, as I say, it takes, if you're using the OpenSees as your analysis, it will take whatever OpenSees model you have, and that could be a model of anything. You might even want to include that also might include the soil and some continuum model of shear building. So it could be anything that in OpenSees input model. Again, all you have to specify are the column lines for the output.
Well, you answered the second question there as well. We went on to, is it even, does it have application to geotechnical models? So the answer, I guess, there is yes.
Yeah.
Then more specifically, is there a recorder I can use to get the residual drift ratio from EEUQ?
It's not in the standard. It probably should be, but again, you could use OpenSees in the recorder option.
Okay.
You can specify your own recorder to do that.
Fantastic. Well, I think, Frank, on behalf of all of the attendees here, we thank you very much for introduction to EEUQ. I will remind the viewers and the attendees to look for or send more questions in through Slack if there are additional questions. First, maybe have a look through the documentation. If there is a bug, submit that as a bug ticket at DesignSafe. General questions or support can be provided through Slack, and look for that Slack channel dedicated to EEUQ. And thank you again, Frank. At this time, this concludes today's webinar.